So my name is Ari, and I'm here to share with you what we have learned over the last 3 months at SkillUp by starting to use Airflow. So at SkillUp, we are marketplace of professional trainings in France, and this market is quite fragmented and not very transparent. So what we do is we go to different sites, look for trainings, their sessions where they take place, and we integrate that into our system, and we allow RH and employees in France to book, to search, and to compare those trainings. So as we are trying to integrate more systems, more sites, and also try to keep the data more up to date, we're looking for a new system that will allow us to get some transparency over the different tasks that are running, that will allow us also to scale, and that will also force us to use some good data engineering patterns. So we went for Airflow. And Airflow, it's an open source project that's written in Python, and it also allows you to create dynamic workflows in Python. It was created at Airbnb, where they use it for very big pipelines. They do things like A/B testing with that. So this also used at some companies here in France. BlaBlaCar. There's also a blog post where Drivey use it for data quality, I think. And right now it's under the incubation of the Apache Software Foundation. So we use it with Docker. So in production, we do have 5 different Docker services that correspond to the architecture of Airflow. So you can think of Airflow as there is a metadata database. You can use basically whatever SQL Alchemy can read from. We use PostgreSQL, and this is used to store all the different workflows and all the different tasks that you have registered and created with Python code. It also stores information about statistics regarding those tasks, when they started, when they finished, how long did it take, whether they succeed or not. There is a scheduler. This scheduler will run at a heartbeat. By default, it's something like 5 seconds. It will look for all the Python files that there is at a certain folder, and it will parse a structure of the different tasks and workflows. So that will be stored in the PostgreSQL database. And the scheduler will also send some tasks that need to be executed to a Redis broker. Those tasks are picked up by an executor. We use a Celery executor that allows us to have multiple workers that run in parallel. There are some other executors also, can be run on several machines. And finally, there is a web server and user interface that is quite practical, allows you to see what is currently running, whether things fail, and it also allows you to take some actions such as launching some tasks. So now we'll see, have a look at the DAG view in the website, in the web server, sorry. This is a list of the DAGs that we currently use at the SkillUp. First, DAG is just an acronym for Directed Cyclic Graph, and it's a way to think of workflows as a set of tasks that are connected, that depend on each other. And Airflow will make sure that those things are run in that order. So we saw some graphs at Bonobo. Here's similar graphs, but the idea is different. At Bonobo, the different nodes that we saw, they can send data to each other, so that, as Roman said, once you have finished processing some row of data or some record, you can start doing something else. In Airflow, it's different. 2 tasks that depend on each other. The first one needs to completely finish before you go for the second one. And the task will communicate through an intermediary system, such as a database. So you'll extract some data, load it into a database, and the second task, after that's finished, will transform it, and so on. But tasks can still pass some metadata to keep up with some context of what you're doing. So here we have a list of DAGs. The first one, they're all on, so they are currently activated. The first one, it's called FastTextTrain, and it's run daily. And it basically runs and trains a machine learning algorithm that we use to tag trainings. It has 4 different tasks, and all of them they completed successfully on the last run. Then we can also see that there is 12 executions of this DAG. 6 of them they succeeded, and 6 of them they failed. At the end there are some links. The first one, it allows you to rerun that DAG at the current time, and the other ones allow you to have a more detailed view of that DAG. The second DAG is the simplest one. It runs daily, and it has only one single task. That task is responsible of interacting with an external system, scrapping hub, that we use to launch the spiders. So that task, basically what it does, it registers a list of spiders that we have in an external system into our MongoDB database. The third task is a little bit more complicated. It's run hourly, and it has a lot of tasks. This task here, this DAG, sorry, it's responsible of extracting the scrap data, and if there is new data, it will trigger another DAG. So it's responsible for triggering all the other DAGs that we see here that they are scheduled none. And the ones here, they are all the same graph. We'll have a look at how that graph looks. They just correspond to different sites. And we want to separate that logic, because we may want to turn them on or off or give them different priorities. We see also that we have still for those graphs some tasks that are still currently running that haven't. So the DAG is running because there are still some tasks that haven't completed. So first look at the code. It's quite easy to create a DAG and a task. You just need to instantiate an object of the DAG class, pass it a DAG ID, in this case a scrapping hub spiders, some default arguments, and then a schedule interval. We want to run this daily. Then we set up the catch-up policy as false. That means that we don't want, when we first activate that DAG, we don't want Airflow to run one execution for each missing interval. Here we're saying that we want to start this at 1st of January of 2017. If we wouldn't have said that, Airflow, it would have run once for each day that is missing from today to this date. And that comes from the idea of how Airflow was first designed. It was thought as something that will run at the end of the day to process the data for that day and generate some reports. So if you started today, you want to still to process all the historical data. So that's a backfill. And we don't do that because we want to handle ourselves which data gets processed and when. To create a task, a task is associated to an operator. Here we're using a bash operator. A bash operator takes just a task ID and a bash command, and it's associated to a DAG. So the bash command here is just a Python command line that we execute and does that extraction. Here we have a look at the graph view of a specific DAG, the scrapping hub trigger. We can see that it finished with a success code, that it was scheduled at a certain time, and here we have some of the tasks that are registered. So there are 2 kinds of tags. There are the struct tags and the trigger tags, and they're linked by an arrow. So it means that you first do this, and when this has succeeded, you do that. If this fails, you don't do that. So the first task, as I said, it extracts the new data that's been scrapped, and the second one, if there's new data, it will trigger another DAG execution. So here we have a look at the code that allows you to generate a task dynamically. So dynamically, I mean that you can do that. So this code is read every 5 seconds. Every 5 seconds, the schedule will, well, for us, 15 or 30, I think, because otherwise too much load on the system. But it will read that, and you'll see, it will query the database, this query or MongoDB database, see how many spiders we have registered, and for each one of them, it will create 2 operators, 2 tasks. One, the bash operator that will extract the data, and the other one, the trigger DAG run operator. The trigger DAG run operator, it takes a Python callable that will be responsible of deciding whether we want to trigger that other DAG run or not. We also want to pass some context, which spider we are considering for each case, and we assign it to the DAG. Finally, we use the Python B shift operator to say that we want to run this and then that. The Python callable that we pass to the trigger DAG run operator, it's get automatically injected by Airflow the context and some already pre-populated DAG run object. we take some information that we pass from the parameters, the spider, we query our database, we see if there is a job that hasn't been extracted, and then we update that job and we populate the DAG run object with some extra information regarding the type of item that we are dealing, if it's a training, if it's a session, if it's a review, and the job ID. And then we pass that, and that will be picked up by another DAG that will execute with those parameters. So here we have a look at our main DAG that is the same for each site that we scrap. We can see that it's still currently running. It's not a schedule, it's been triggered at a certain time, and it's running because there's still one task that hasn't finished, the validate training task. So we see that there are a little bit more of tasks, and there's a certain path that the execution has gone through. We see also that there are different types of operators. We have bash operators that we have already seen, but we also have Python operator here. We have a branch Python operator that will tell us, based on some logic, whether we want to do that or whether we want to do this. And then there is also a special kind of operator, which is a sensor operator. And we'll have a look at all those three kind of operators. Another thing to say at this moment is that each one of these tasks can be rerun individually. So it means that I can click here if I'm not happy with my model, or if this failed, I can click here and say clear the state and run it again. When doing so, it's important to think and make that your tasks are idempotent and atomic. That means that you should be able to run this multiple times and don't have side effects. And this just replaces the tags with new ones. And this will, well, I want to make a little bit of emphasis before moving on what this one does here, because it's the compare train is the one that has the most load on the system. And this one, basically what it does, it extracts the raw data that we have scrapped and the data that we have on production on Neo4j, and it will compare. It will tell us how many trainings have been updated, how many trainings have been added, how many trainings have been removed, and we also have statistics about how many praises have been updated, how many durations, how many program titles, everything. And that gives us some confidence over whether the new scrap is valid or not. And if it's not, we will have some clues over what may have broken. If before there were 90% of the trainings have a price and now only 5%, then probably either the price has new format or it has been moved somewhere else in the website. For now, we do this validation, we do it manually. It means that we have internal dashboard with all these statistics that we'll use to say, okay, validate this training. And this task here will query the database until we validate or invalidate this training. And in the future, we hope that as we collect more data, we will be able to do that validation automatically. Before we saw how we could create a task dynamically, here we'll see how we can create DAGs dynamically. So basically, it's a similar pattern as Bonobo. There's a factory function. It creates a spider DAG that will return a DAG, like a graph. So there we do all the logic. We create a DAG. We set up I've cut some code because it didn't fit. But we create some operators, and then we set up the dependencies with the bit shift operator, and we return that DAG. So this function will be called for each spider, and will register a global variable in the global namespace. That will be picked up by the scheduler, and it will be registered in the database. I want to just tell you also here, this syntax here, it uses Jinja templating. There are 2 curly brackets, and this is actually after injected by Airflow. It will take some data from the DAG run configuration and will be injected there. The Python operator is quite simple. It just takes a Python callable, in this case store DAG running job. Again, because we are saying that we want to provide context, Airflow will inject some data in the keyword arguments, such as the DAG run, including some data that we are passing always in the graph. Which job are we dealing with? We'll update the database just to make an association between the current DAG and that job, and that will be useful for our dashboard. And then we have also the branch Python operator, which is the same as the Python operator. The difference is just the function should return the ID of a task that follows. So it allows you to go one way or the other. The sensor operator, the last one, it's a special kind of operator, as I said, and here we're actually creating our own operator by subclassing the base sensor operator. And we implement the poke method, which is a method that will be called every 60 seconds. It will query database, and it will check whether the job has been validated or not. It will do that for 7 days. Then it will time out. So we've seen quite a few things. If I would summarize it, we'd say that Airflow thinks of a DAG as a workflow of tasks with dependencies. A task is always defined by an operator. We have seen some of them, but there are many others. There are tasks and operators to run things on external systems, that is Spark, maybe one day Bonobo, I don't know, databases, and so on. And DAG runs, they can be scheduled, trigger, or launch manually. So thank you. So if you have any questions or comments, please. Lucky one up.
Thank you. Yeah. So what happened when you update the DAG? What parts of Airflow do you redeploy, or is it all automatic?
Yeah, in the case of the dynamic DAGs, it doesn't pose a problem if there's a new spider ID that's been returned, because it's now registered in the external system. That doesn't pose a problem because it will just appear on the dashboard after some seconds. But if you change, that's a really good question, because we had some issues trying to fit our model into Airflow. Because if you change DAG dynamically too much, it will mess up with some of the screens that we didn't show that show statistics. So Airflow is think of slowly changing graphs. They can change, so we added the DAG trainings some time later, but it shouldn't change too much, because otherwise it actually mess up with things. So I don't know if it was that. Question. Okay.
Sorry, we sort of out of time, so we're going to stop there. Thank you, Eric.
Thank you.